What am I gonna cover first? Well, talk about why do we need to automate things? And the answer to that is pretty simple. You guys were talking about it earlier about how to quickly switch from band to band to work all the DX that pops up. You don't want to make a mistake. We'll cover the transceivers and how they provide band data and frequency data to external peripherals, the amplifiers that can use that data, band decoders that will help drive an antenna switch or antenna switches that have their own built-in band decoders. For multi-operator stations or SO2R type stations with two rigs available, you would need a set of bandpass filters to switch automatically to, and perhaps you have an outboard tuner or one built into your amplifier, and you obviously want it to tune to the right segment before you do any transmitting. And we'll summarize this at the end and have plenty of time for Q&A, I hope. So why do we automate? Well, contesting is hard work, especially DXing can be hard work too. And you're going to get tired, you're going to get sleepy, and fatigue will lead to mistakes, as you can see. So you don't want that to happen. You want everything to be automated because it'll prevent a disastrous mistake like transmitting full power in a no antenna or the wrong antenna or transmitting your rig on 80 meters while your amp is on 10 meters, something awful like that. You want to let the machines do what they do best, which is automatically switch themselves, and you want to do the rest. Well, you can not get much rest if you're in a contest situation. So what are the things that should be automated? Obviously, your computer log should be automated. It should automate the date and time and the frequency, the mode, call sign, the exchange that you received. All of that should obviously be automated by computer logging rather than pencil and paper, unless you're a poet or something, you don't have a laptop with you. On CW and RIDI and even voice keying, you can automate the transmissions such as calling CQ, yelling your call sign in a pileup. You can automate that, and that's a good thing to do. Using the voice memories in the radio is particularly good. Changing bands on the rig, you want it to automatically switch the antenna, the amplifier, the tuner, any bandpass filters or coax stubs if you have them. And for a multi-transmitter or SO2R, those are essential. But what don't you want to automate? And obviously, I don't think the CW copying should be done by code readers. I don't think they work very well. Maybe they'll get better with AI these days, maybe not. But I don't think you also want to blindly trust every cluster spot. There's some good nodes like V7CC that automate skimmer spots, and they tend to eliminate uniques and only show a spot when two different skimmers agree. Though that can be pretty good, but the human spots where you don't see a pound sign on the spot, that means a human spotted it. They tend to mess up quite a bit more than the skimmers these days if you're connected to a VE7CC node. And I don't think it's a great idea, especially contesting, to automate the letter by letter transmission of your call sign because it sounds bad. Oscar, Hotel 2, Bravo, Alpha, Delta. It just doesn't sound natural. And I don't think anybody is going to want to be attracted by somebody calling CQ with a call sign like that. But obviously, if you have a speech disability or something, then use whatever tools are available to make voice contacts. Band change decisions, when should I go to 80? When should I go to 20? Don't leave that to the computers, maybe AI someday, but right now that should be your own decision. And here's a kind of a subtle one if I'm more of a contester than DXer. And when you have a pileup going and you're calling CQ, you don't need to sign your call on every single contact. Some of the rules require every 3 minimum, but how often you sign your call should be kind of your own decision. Automating it so that the software automatically signs your call every 3 or every other or whatever, that tends to do it at the wrong time. When there's 4 or 5 guys calling, you don't have to sign your call when you know there's nobody but one guy calling. Then you do want to sign your call at the end of the exchange. So that should be your own decision. And obviously where to put your VFO when you're calling in a pileup or finding a clear frequency. I don't believe you want to automate that kind of thing. Automatic band changes and your equipment can follow. The main problem is that the main issue is you want speed and reliability. That's important. You want to always go to the right band and always be fast, not be slow. And therefore, my recommendation is to use the hardware to do it, not a PC software driving everything, because sometimes you have to reboot your PC or your RF gets into it, or it crashes, or power goes out or something. You want to be able, I think, to use any station automated fashion as much as possible when the computer is completely off. It's not always possible. Some transceivers like the Flex Radio, they require a computer to be running. But if your transceiver supports it, use it. All transceivers provide band data or operating frequency data to peripherals. There's some tricks to make different transceivers work. And the peripherals are designed to listen to transceivers, either band data, and we'll go over what that is, or the operating frequency of the radio. They also often have a frequency counter in them, so that if the band data cable gets disconnected, or you don't have anything, or the band data is wrong, or the line opens in the cable, the tuners will usually have, and their amplifiers will usually have an RF frequency counter. And like the old Alpha 87A, you just tap the key and it figures out what frequency you're on and switches to the right band. But all those involve a little bit of hot switching, and I try to avoid that by having the amp and tuner move first before you transmit any RF. So the transceiver is going to drive your peripheral. So obviously, in most situations these days, we have a USB or maybe an Ethernet connection from a PC to a transceiver, USB Type B, or maybe an Ethernet port on the modern transceivers. And it has a second output port that provides band data or RS-230 data or ICOM CIV data, which is like a two-wire serial port. And that data can be then monitored by automatic amplifiers, so that they automatically switch to whatever the transmit band of the transceiver is. That data can be fed to a band decoder to automatically switch your antennas or bandpass filters. So the band decoder usually drives the antenna switch, a relay type antenna switch. It can drive bandpass filters, as I mentioned. And you may also have an automatic that can automatically move to the right band as you change bands. And that can be automated too. Some people say, oh, I don't want to use the step IR, keeps jumping between segments. Well, there's ways of overcoming that by switch every 50, and then you don't have border problems on the FT8 frequencies. So what is band data? Band data is just giving the band of transmitter to the external device. It doesn't give you the frequency. It doesn't give the device the frequency. It's really ideal for switching amplifiers that are broadband and solid state. They don't have tuners. I've listed the popular solid state tuners here. I guess I need to add the ACOM 2020 S to the list. It's very new. I haven't worked with a customer that has one of those yet. The Power Genius and some of the SPE amplifiers that don't have tuners, but most do. And then band decoders also are great for driving antenna switches. I've listed a number of band decoders and antenna switches here. I'll show some pictures later. And those are driven by band data, not the frequency, just the band. So we're talking about an automated tuner that needs to go to the right frequency segment before you do any transmitting. And that includes all the devices I've listed there, different flavors of that now. And it's a small antenna called the Baby Loop that has a controller that also reads frequency. What is band data encoding? Well, it uses these just four little lines, 4 bits that are high or low, 0 or 1, you can think of it as. And it's a binary coded decimal, which is just a fancy binary code, 1 per band. And that is in the table at the bottom here. Let's see if I get my laser pointer thing to work. So for example, 160 meters, and A is going to be high and the rest are going to be low. And that tells the device that you're on 160 meters. Yaesu and Elecraft use this scheme. ICOM uses a band voltage and a legacy band data, they call it. And that is only a different voltage for each band. And you can see there's a problem with ICOM, and that is they only support 17 and 15 meters, 12 and 10 meters on the same voltage. So they can't distinguish between those two work bands and 10 meters. But for contesting or typical use on 10 and 15, that works fine. A flex radio can provide this type of 4-bit band data output. It requires a custom cable. I forget the model number. Kenwood radios, however, they do not have any band data voltage. They do not have any band data pins. They only have frequency data, and that's good enough for many devices. So here's what the connectors look like, and nobody can get the same connectors. So every radio's got a different connector, and I've learned about them all. These Yaesu radios use a 8-pin DIN, but it's not the common 8-pin DIN plug that you'll find. It's an uncommon 262-degree horseshoe-shaped 8-pin DIN. FTDX 10 and 1200, they're using an uncommon mini DIN. The standard 8-pin mini DIN won't fit in their connector. Yaesu 101 series use a nice fat DA15 connector, which is very standard and easy to wire. And fortunately, the FT710 uses a standard 8-pin mini DIN, not a proprietary one. But they do something a little tricky here, and that is they do have the 4 band data pins, but then they can reuse 2 of those band data pins labeled RXD and TXD based on a menu setting. That can actually be RS-232 or serial data at the TTL level, 0 to 5 volts instead of the usual RS-232 voltages. Elecraft has the same band data table that we showed before, number 1 for 160 meters, and they have the 4 band data pins, as well as a keying output on this ACC connector, the same on the K3 and K4. Now, ICOM doesn't have 4 pins, they just have 2 pins. They're labeled band and 8 volts reference, and essentially that's where the band data is output. And they don't use the same connectors on all their radios. Most of their legacy radios use the 7-pin DIN, but the 7300 and 7410 use a 13-pin DIN plug. No fun to solder, but fortunately only need to put 2 wires in to get band data to work. So what about Kenwood radios? They have a serial port. They label it COM. It's a male connector instead of a female like other radios. And it's independent of the USB connector on the radio. So that means devices can use this independent of your PC. And only one device can ask the radio for frequency on this port, and it'll respond with the frequency data, and you have to set the baud rate. Unfortunately, there's some rigs like the FTDX 3000, 5000, 9000, and the Elecraft K3, as we'll get to later. They also have a serial port, but it does not, there's no USB connector, or the FTDX 3000 has a USB connector, but you can only use it or the RS-232. You can't use both at the same time. They don't operate independently. So when you have that situation where the PC software has to connect and pull the radio, and the peripherals have to just listen in on pin 2 and pin 3, which is the transmit data pin, that has to be left open so only the PC talks to the radio and not the device. Otherwise, you can't wire 2 pin 3s in parallel. They conflict and you get nothing. So the trick there is to use a special Y cable that wires the pin 2s in parallel, but not the pin 3s between your device and your PC. And that's what I put inside my serial box, which I think it was K7TM was asking me about earlier. So you don't have to wire a Y cable. The ASU FTDX10 and 101B, they do have a serial port, but fortunately it operates independent of the USB, so there's no conflicts between your PC using the USB cable and your device using the RS-232 cable. And then the Elecraft K3 or K3S, we're back to one serial port again. There is a USB connector on the K3S or the upgraded K3, but it doesn't operate independently of the 9-pin. So then there's something they fixed in the K4 where you really do have an independent RS-232 connector. So again, you have to use a Y cable or serial box to share a K3 or K3S serial port with a peripheral and a PC. ICOM rigs have a remote jack. It's a 2-pin connector, 3.5 millimeter mono plug. You can use a stereo plug and just tip and shell and ground. That works fine too. It's a 2-wire serial bus, 19200 baud maximum. And there's an important menu setting to make it work, because as you can see, the ICOM rigs, like everything but the 705, have a USB connector and a legacy CIV connector. And you have to set this menu USB CIV port to unlink from remote so that the 2 ports operate independently. Then your PC can use the USB and the devices can use the CIV. Some rigs like the 7700 do not have this option, but they do have a 9-pin serial port, so it's still possible to make it work. So what about the amplifiers? Well, most solid state and broadband are broadbanded, and therefore they only need the band. But if they have a built-in tuner, then they need the frequency. Many of them are designed to get the data by band data or RS-232, or maybe either one, or ICOM CIV, and some even support Ethernet LAN connection. But there's no general standard for broadcasting frequency data, so it's kind of a proprietary connection. And the great thing is, as soon as you change bands on the rig, then the amplifier changes bands. You don't have to transmit any RF. And all amplifiers will almost always have some kind of frequency counter in them to automatically switch the RF input doesn't match the band. That can cause problems if you have a transmitter that you put on real low power and starts producing a bunch of harmonics. It may not be enough RF for the frequency counter to give an accurate answer, and then you have problems. ACOM 2008 amplifier with the so-called new RCU, which is pictured here. The remote control head is the RCU. That's the device that has this CAT connector on it, and it has both the RS-232 voltage pins and the TTL voltage pins. The older original one also had a keying pin, but they put that away, unfortunately. The labeling is standard, the same as a PC. They use different pins, and it is a 15-pin connector, not a 9-pin serial connector, but it has serial data on it. All the other pins don't really have anything on it on this amplifier. They started to use those pins in a more logical scenario in their modern solid-state amplifiers. I should probably add 2020S to this list. As you can see, they have the band data pins, and they also have the RS-232 and TTL pins. And they, unfortunately, have reversed them so if you upgrade from a 2000 to a 1200S, you got to move your pins around because they didn't use the same one. Meritron can support this. They require a box called the ARI 500, and it goes to your radio, and they provide a cable for that, and then it drives these wires to automatically switch bands based on band data. Elecraft KPA 500, it's the same as the KPA 1500. You have the band data pins, band 0, band 3, and so on, and you also have an ICOM CIV pin, so it can track ICOM rigs. And there is a 9-pin RS-232 connector, so it can track Kenwood radios. But it doesn't have a CIV connection. So again, you would have problems on the work bands getting this amp to switch automatically to the right band. Same story with the KPA 1500, almost the same connectors. They took away the 9-pin serial connector and they replaced it with a 3-wire tip, ring, and sleeve. That's what TRS means, the stereo plug, basically. 3.5 millimeter labeled Xever serial on the back. And that gives your RS-232 data for Kenwood and Yaesu. But they did add ICOM CIV support. So the Elecraft KPA 1500 does automatically track all the bands of an ICOM rig, which is a sweet new addition, not available in the KPA 500 or the KAT 500. Flex Radio has their Power Genius XL. It supports sort of everything. They've added kind of the kitchen sink here. They got 15-pin connector with band data inputs. They've got 9-pin serial connectors for 2 different transmitters. This is a SO2R amplifier, 2 radios, 1 amplifier, 1 at a time. And they have a CIV connector for ICOM rigs. So it can do it all, which is kind of nice. The RF kit, not so nice. It has a LAN connector and a USB connector labeled CAT. It does not have any band data pins on the multi-data interface, unfortunately. So you have to connect your own USB to serial adapter or USB to CIV adapter to this CAT port and connect that to your radio. The S-Box USB can also provide that function to an RF kit. SP Export, similar to the modern ACOM, they have band data pins, which you would use those if your SPE amp has no tuner internally. It also has RS-232 and TTL, but they all use different pins, different connector. It's a 2-row 15 instead of a 3-row. But fortunately, they did put the relay and ALC and other things on these 15 pins, so you don't have to use these RCA connectors. You can do quite a bit with just one 15-pin cable. The amplifier, it is not a true SO2R amplifier. It has 2 inputs for 2 radios, but only 1 at a time gets the transmit antenna. They have an SO2R port, but it's for a receive-only antenna. So it's not a true SO2R amplifier. They make an expensive peripheral you can to it that does make it into one, but I don't know too many people that have that. For those who have an older relay type antenna switch with no band decoder, you would add a standalone band decoder, and that some of them work on band data alone, some work on CIV or RS-232. And you would connect that to your antenna relay box, the output of it, and the input goes to your rig. And typically the output is going to be 1 pin per band, 13 volts out on to drive a relay, or 0 grounding of voltage to bring a relay down. That's called source and SIC outputs of a band decoder. If you have a tri-bander where all three bands go to one antenna, you can jumper or program the band decoder to drive the same output pin for those three bands. So here's it's a collection of band decoders offered by Array Solutions, as well as the Shackmaster SM8. And they have, as you can see, they have a CIV connector for ICOM. They have an RS-232 connector, and that they've also used some of these pins for band data. They kind of cleverly use those pins because you don't need all 9 pins to do RS-232 in most cases. And they have this proprietary Shackland thing to connect devices to each other. So that's Bandmaster 5 is still in production. I don't think I think the Shackmaster is. Don't know. I guess this antenna port here is for I'm playing a Wi-Fi link up or not for a TX antenna. So they got clever with their connector. They have on pin 2 and 3, which is your standard RS-232 pins. That's your TXD pin data to the radio. It can pull the radio data from the radios on pin 2. And then they use the other pins for band data and some other things. And ICOM band voltage is also supported. It's kind of a clever way of using a 9-pin connector, but you don't want to wire all 9 pins. Elecraft has their old KRC2 band decoder, not too popular device. It doesn't have any lights to indicate what band you've been switched to, and it's a little tricky to program. So, but it is available still. Ham Plus makes their band decoder. I use one of these at W7RN when I operate there. It has, as well as the others, CIV connectors. It has a nice feature, which is a send input and output. That's your relay keying to the amplifier. So the nice thing about this switch is if it sees your radio is in transmit mode, you key down, it won't let you switch antennas, which is good. That prevents hot switching. And it can network with other switches so that only one station at a big multi can get a particular antenna. This little send light lights up when it detects your rig is transmitting. This one is the one I've used in my shack for many years. Unfortunately, it's no longer in production. Elecraft, the device maker was sold to DX Engineering, and they decided they didn't want to make one, so they don't have the top 10 available. But if they come up on the used market, I would recommend getting them. They can do at least for the contest bands in the older model, 160 through 10, and then he added all the work bands and multiple antennas per band in the bigger band aid, he called it band decoder. If you want to go the cheapest possible route, you can use Unified Microsystems BCD14 band decoders with a high side driver if you need to have a 13-volt output. I built one of these for a guy. It took many, many hours of work to take these two boards and convert them into this. He also had some external switching. It took hours to crimp all these little connectors and get everything together. I would not recommend going this route unless you're really tight on a budget and don't mind doing a ton of soldering and assembly work to build a band decoder. What about antenna switches? It can be, as I said, the relay boxes usually can be controlled by 1 or 2 band decoders. They switch you to the correct antenna automatically, and they are also pre-configured so that 2 rigs can't use the same transmit antenna at the same time. They use low-loss, high-power relays. I used an Ameritron RCS8V for years. This switch box you see down here is strictly manual. It doesn't have any band decoder in it. You replace that switch box with your band decoder, and then the bands switch automatically. These have been very reliable for many years, even though the construction is somewhat light and it's a plastic case and not shielded. I never really had much problem with it. They perform quite well. The Array Solutions 8-pack used to have a 6-pack. Is another method of automatically taking 2 radio inputs, 1, 2, can switch to any one of 8 antennas, and it's driven by voltage and some other tricks on their band decoders. Flex Radio has an 8x2 switch called the Antenna Genius, again designed by 403. It has band data inputs, 15 pins, but unfortunately, even though it's the same connector as Elecraft and ACOM, it does not use the same pins for band data. It also uses optical encoder because if it's the only thing connected to the Elecraft rig, it works. But if you start to wire 2 things in parallel, like a KPA 500 and this antenna switch, now you need to pull up those band data lines to 12 volts to get it to work. The optical encoders drain too much current, and that prevents the 500 from properly switching. But that's another trick you can do inside my Y box. I have the pull-up resistors and a 12-volt input, so you can make band data work with this device. And the same problem with the Power Genius XL. Ham Plus is the output of the band decoder. It can take, in this case, 2 inputs and any one of 6 outputs, and they have other models that can do up to 4 inputs and something like 6 outputs or maybe more. This is the switch I use in my shack. It's a Microham double 6 switch. It's built like a tank. It has 2 inputs. The control cables are very simple. They're 6 wires plus ground. Whatever pin is active, that selects the port. So my band decoder drives this double 6 switch. There's good RF isolation between the ports because I have 2 1500 watt radios going in here, and the isolation is very good. And with bandpass filters, not much of a problem. Bandpass filters are a must if you're doing SO2R or multi-op or even field day, so that, for example, 15 meters isn't overloaded by 20 meters, or 20-meter harmonic isn't too loud on 10 meters. And it's typically the 100 or 200 watt bandpass filters are available. There are high power ones available from, VA6AM, I think, and some others, but they have to be much larger to handle. And generally, a bandpass filter on the transceiver side, between the transceiver and amp, is good enough for most situations. It doesn't obviously attenuate any in-band signals, so you can't have 2 stations on 15 meters and expect bandpass filters to help much with that. But you want them to switch automatically because they can be burned up pretty easily by transmitting on the wrong band into a bandpass filter. So here's a plug-and-play solution provided by Array Solutions as their AS419 bandpasser 2. It's also sold under the Surefire name, BBF100. I can't see any difference between them except for the labeling. I believe at one time DX Engineering was selling the Surefire version. It has a built-in band decoder for Elecraft and Yaesu. That shows you the 4 band data pins, A, B, C, D here. And you push buttons on this to switch it to band data mode, and then it reads that as band data. Or these pins can be output, 1 per band, but if you're using some of these network inputs. So that's a good band decoder for a Yaesu or Elecraft rig. And then that can drive the output, your band decoder of an old Dunestar 600. Not by modern standards the greatest bandpass filter in the world, but it does take an automated input, 1 line per band. I think it wants a sink or source, 13 volts or a ground to indicate which band to go on. DX Engineering was selling this version of a DXE419. It doesn't have a built-in band decoder. It also needs to ground one of these pins on the connector to indicate what band. It has some nice indicator lights of which one it's going to. I think it also has an automatic and manual mode for you to switch the bandpass filters. Not too many folks in this country have this one, but it looks very nice. It's the OM Power OM6BPF 6-band bandpass filter. Takes the band data pins direct, so it has a band decoder built in for Yaesu or Elecraft, and will automatically switch in a bandpass filter just for the main contest bands 160 through 10, no work bands. I think it just bypasses itself when you pick a work band. What about automatic antenna tuners? Well, there's some of those in amplifiers and some external ones. You want to automatically program the tuner for each segment, like 25 kilohertz wide tuning segment, and you want it to automatically go to that, so you don't have to hit the tune button and have it switch. You want it to know the frequency of the rig before you do any transmitting, and then it can restore that tuning solution and before you do any transmitting, and it'll bypass itself automatically if you say run the tuner and there's a low SWR in the antenna. That most smart tuners will say, okay, we don't need to switch in any tuning here. We'll just bypass ourselves when you get to this segment. And most tuners can remember multiple solutions per band, and some support multiple antennas on the same segment. They pick the proper tuning solution automatically. Elecraft AT500 tuner has 3 antenna outputs, 1 transmitter input. It can handle up to 500 watts, and it has also this PTT input and output here. Those are also on pins on the 15-pin cable. They operate independently, and what that is designed to do is open the keying line to your amplifier while the tuner is hunting for a solution. That's very important so that you don't feed high power through the tuner while it is trying to find a solution. Always want to do your tuning at low power, and it will remember band data segments. It gets the frequency for LCAF rigs by proprietary data here, and the PC data jack, this 3.5 millimeter stereo plug, can be used to get the frequency of Kenwood rigs or a flex radio, which is equivalent to a Kenwood. The Flex Radio Tuner Genius, again, has similar connectors to their Power Genius, a CIV connector for ICOM. It has band data input, but that's really not very useful for a tuner because it needs to know the frequency, not the band. And it has ordinary RS-232 male serial connectors to talk to Kenwood radios or L-Craft, and it will work in listen-only mode with only pin 2 connected. This one is kind of hard to find these days. Kessler Engineering AT Auto. It looks kind of like the Palstar AT Auto, but it is not the same. Palstar doesn't have automatic band tracking. The Kessler can track at least Kenwood rigs by RS-232 instead of by RF sensing. And then you have also step-by-R antennas. They have a way of automatically tuning themselves to the frequency of the rig. A lot of people turn that feature off because they don't understand how it works. I think it should be left on once you program all the segments. That way you can't transmit into the antenna tuned to the wrong segment. And it also has a PTT interface, which I'm not seeing in this picture of the back of the SDA100, although it should be there. There is a PTT interface right here on the back of the optimizer that opens the keying line to your amplifier while the antenna is tuning. And that's important, again, so that high power can't damage the antenna while it's moving to a new location. And I recommend always hooking that up. If you need help with how to make that work, I'm happy to explain it. And you can use my serial box to connect to the step-by-R. They use an RS-232 connector here, but you get confused by seeing data in, data out. You think, oh, I'll just plug the computer in one side and the output goes to the radio. No, it doesn't work that way. The data in is to monitor the RS-232 data and connects to your radio. And data out is designed to connect to a second controller so they can both track together if you have a stack of FIRs or something. You can connect a computer by running PST Rotator AZ to the data out connector and control it by PC software using something like PST Rotator, but then the data in connector doesn't work. So I prefer letting the radio track automatically with the step-by-R. The Ultra Beam RC006 controller operates similarly. It has a data in connector. They use the female connector here instead of male. And again, they have a tuning relay interrupt, but instead of a handy 3.5 millimeter connector, they give you these little pins, and one of them opens up when it's tuning. And again, you want to wire this in series to your keying line of your amplifier. Looks like it has a CIV connector as well for ICOM frequency tracking, which is nice. Well, how do I get all of these things to talk to each other? Well, if you guys recall this diagram from early in the talk, just to review, we have our PC talking to the transceiver. We got a transceiver with band data outputs, maybe CIV outputs, maybe RS-232 outputs. That can drive a band decoder, that can drive an automatic amplifier or a step-by-R antenna, and maybe the band decoder drives bandpass filters and an antenna switch. So it's a lot of cabling, but it can work. I mean, Flex says do it all on Ethernet. You can do it that way, but Ethernet cables, if they're unshielded, and operating at 100 megabits, can generate RFI in 20 meters. And again, you're kind of depending on computers to do the work instead of simple pins that go on and off. You can buy some interface cables from DX Engineering or eBay, but you have to be careful because many pre-made interface cables are just doing band data, and they're really not appropriate for a tuner or an amp that has a tuner that needs to know the frequency, not just the band. And they may omit the keying connection, which means you need another cable to do the keying. You can, all of the manuals document their band data connections, and you can try to build your own, but most people would rather not try to solder tiny high-density HD15 or DE15 connectors. It's real easy to short two pins together. I build high-quality cables using crimp connectors for those D-subs, and anybody who purchases one of my boxes, I'll be happy to build them a custom cable if they need it. But things do get more complicated if you have to share band data outputs to different devices or share the RS-232 connector to multiple devices. And that's where my Y box comes in. I basically made a fancy Y cable out of it. You can buy the Winford Engineering Y cable that's pictured there. It's about the only one on the market that guarantees all 15 pins to be wired to both connectors. A typical VGA splitter looks like this, but does not work because they omit pin 9, which is one of the band data pins for Elecraft. And if you need more than 2, or you'd like to break out some of those pins, like the FSK pin for an Elecraft, or maybe an ALC pin on some other device, then the Y box is available. That gives you 1 input, 4 outputs, and 4 easily rewired taps of any of the pins, inputs from a step IR or your PC. And I have a USB version that has a built-in FTDI USB to serial adapter. That's the S-Box USB, I call it. You can even put 2 in, and then you'd have 2 USB to serial adapters. But it's designed to connect your rig, step IR controllers, ACOM SPE, mostly using standard cables. I designed this box so you could use a molded cable instead of having to solder your own and mess something up. And I stock some molded cables that plug into everything. So to summarize this, the key recommendation is that whenever possible, let the transceiver drive the devices instead of using PC software to do it. That way your station still works when the PC doesn't. Use the band data when the frequency is not needed. The band data is great for driving bandpass filters, antenna switches, and broadband amplifiers, but use the RS-232 or CIV data when the frequency is needed for amps with tuners or step IR controllers or automatic antenna tuners. And use off-the-shelf solutions if you're not comfortable, wiring your own cables and connections. In other words, if you don't know what you're doing, don't do anything. Get some help. Here's some references. This talk is linked, a copy of these slides on my QRZ.com page. At the bottom, there's a whole section of presentations. And there's also links to my serial box, if you forgive the plug. Take questions and go back to any slides if you wanted some more clarification. So with that, I'll open it up.
N7UVH, I got a question. When ordering the S box and we fill out that questionnaire that you have, what your radio is and what you want to hook it to, if we kind of get our wires crossed and we don't know what we're doing, can you kind of go, oh yeah, you need this instead?
Yes, that's one of the reasons it's a questionnaire as opposed to a form that makes you pay money. It just tells me what you kind of have and what you think you need and what kind of cable lengths you think you might need between stuff. And for example, I don't have listed there a female to female serial cable, which is what a Yaesu or Kenwood rig needs. And I figure that out just based on, as long as you tell me all the boxes that need to connect together, then I know what you need, and I'll give you a whole proposal before you have to pay any money. So
thank you.
Thanks, Murph.